In this video, we will review the proper termination procedure of a System 1850 multi-conductor MI power cable using the Pyrotenax Pyropak termination kit. Copper-sheathed MI power cables are classified by UL and ULC as 2-hour fire resistive, and the improper termination of the cable can jeopardize its integrity and reliability. Before we begin, let's double-check that your Pyropak kit contains all the necessary items you will need in order to terminate the cable correctly. Inside your kit you should find 2 spacer disc and insulating sleeve assemblies, 2 brass gland connectors, 2 brass self-threading pots, 2 torque tags, and 1, 2, 4, or 6 packs of mastic sealing compound, depending on the pot size. Also make sure that you have all the tools required to perform the termination. A Pyrotenax Sheathmaster tool for stripping MI cables up to 3/4 inches in diameter. A ratchet sheath stripping tool for cables larger than 3/4 of an inch in diameter. An MI crimp tool. A Pyropak tool, and a Pyrotenax hand vise. In addition, check that you also have the following set of standard tools in your kit. Do not proceed until you do. For this demonstration, we will terminate the end of the multi-conductor cable inside of a fire alarm control panel. First, ensure that the end of the MI cable is straight for the tail length required, plus approximately 3 inches, 7.5 centimeters. With a hacksaw, cut the end of the MI cable square, using a hand vise to hold the cable in place if needed, and file the end smooth using a flat file. Now, place a mark on the sheath for the tail length required, 12 inches, 30 centimeters being standard, as this is the length of sheath to be removed. If you're using a Sheathmaster stripping tool, place a second mark 1 inch, 2.5 centimeters behind the first mark. If using the ratchet sheath stripping tool, place the second mark at 1.5 inches, 3.8 centimeters behind the first mark. The sheath will be stripped back to the first mark, exposing the conductors. The second mark from the end is only used to position the hand vise for final stripping. The gland connector is an assembly which consists of 3 parts: the gland nut, the compression sleeve, and the gland body. For correct installation, the gland nut is placed first, followed by the compression sleeve, and finally the gland body. It's easier to place the gland connector on the cable with all the pieces assembled. Do not tighten the gland connector at this point. Next, strip the copper sheath off the MI cable. Gripping the cable with the hand vise and using the stripping tool, begin stripping the copper sheath back towards the first mark. Note that the Sheathmaster stripping tool must be adjusted depending on the diameter size of the cable being used. For detailed instructions on how to operate the Sheathmaster stripping tool or the ratchet stripping tool, please refer to the instruction manual that came with the tool. Continue to strip the copper sheath, adjusting the grip on the hand vise as you move up the cable to keep it from twisting. For final stripping, grip the cable with the hand vise at the second mark, and when the stripping tool touches the edge, it will stop and make a clean cut on the cable sheath at the first mark, thus exposing the correct length of solid conductors. Straighten the conductors and ensure that they are evenly spaced. Wipe clean all of the surfaces, including the conductors, to remove loose powder, and visually inspect the magnesium oxide insulation at the face of the cable for traces of copper filings and burrs. If present, you can remove them with a pick or gently tap them out. But do not blow them out, as this can introduce moisture into the end of the cable. When cleaning the conductors, be careful not to remove more powder from the face of the cable than is necessary. Place a mark on the cable back from the end. You will screw the pot onto the sheath so that the back of the pot aligns with the mark. Refer to this table on page 3 of your instructions manual for the correct length to mark on the sheath, depending on the pot gland size. The pot gland size we are using in the demonstration is 3/4 of an inch, so the cable will be marked at 7/16 of an inch, 11 millimeters back from the end. Place the self-threading pot onto the non-threaded end of the Pyropak tool. with the larger hole of the pot facing outwards and protruding past the end of the tool. To know how much length of the pot to leave protruding past the end of the Pyropak tool, reference this table, also available in your Termination kit's instruction manual. Tighten the screw on the pot with an Allen key, ensuring that the Allen screw is tightened onto the knurled end. Slide the assembly over the exposed conductors, threaded end of Pyropak first, until it stops at the face of the cable. Screw the gland assembly already on the cable all the way into the threaded end of the Pyropak tool, and tighten it lightly with your fingers. Now turn the Pyropak in a clockwise direction while simultaneously applying pressure. This will engage the internal screw thread of the pot onto the sheath of the MI cable. Continue rotating the assembly until the end of the copper sheath projects 1/8 of an inch, 3 millimeters, inside the pot. To remove the tool, first undo the Allen head screw on the side of the Pyropak tool, then hold the gland assembly firmly in one hand and rotate the tool in a counterclockwise direction. This unlocks the Pyropak tool from the gland pot assembly and allows for easy removal. Finally, check the pot. The back of the pot should align with the mark made previously on the copper sheath, in our case 7/16 of an inch for the 3/4 inch pot. If one end of the cable has already been terminated, you must test the end-to-end continuity of the conductors with a continuity tester or multimeter to ensure that each conductor will be terminated with the same color sleeves at both ends. Watch our supporting video, Continuity Test, for detailed procedure. Next, you must perform an insulation resistance test using a megometer set to 500 volts DC to check the insulation resistance of the cable between the conductors and the sheath, and from conductor to conductor to ensure that they are free of grounds and shorts. The other cable end must be terminated and sealed, or a low IR reading will result. If unsure on how to perform a correct insulation resistance test using a megometer, please pause this video and watch our supporting video, Performing an IR Test, for detailed test procedures and IR test criteria. Note that low IR results indicate that moisture is present in the end of the cable and must be removed before continuing the termination. When IR readings are satisfactory, immediately terminate the end of the MI cable, or a delay can cause the IR to drop, and the cable must be retested prior to terminating the end. Now ensure that all conductors are straight, and slide the spacer disc and insulating sleeve subassembly over the conductors, anchoring bead end first. To fill the pot with mastic sealing compound, withdraw the spacer disc and sleeving subassembly slightly to allow sealing compound to be packed into the pot. Also ensure that the conductors are spaced an equal distance apart from each other and inside the pot. The pot should still be warm if you had to follow a drying out procedure during your insulation resistance test. If not, heat the cable and then the pot with the propane or MAP gas torch until just warm to the touch before filling with mastic sealing compound. To keep the compound from being contaminated with foreign matter, press it into the pot with your finger behind the wrapper. Slightly overfill the pot with sealing compound, pressing from one side only to prevent air pockets from forming. When the compound starts to come out the opposite side of the pot, push the spacer disc back into the open end of the pot, and gently pull on the PVC sleeves to ensure the anchoring beads are snug against the inside face of the spacer disc. Do not push on the sleeves, as it may force them back through the cap and butt against the end of the cable, thus preventing the compound from making an effective seal. Next, crimp the cap into the pot using the MI crimp tool. Place the pot into the body of the MI crimp tool, making sure that the PVC sleeves, conductors, are inserted through the center. The end of the pot with the spacer disc must fit inside the 3 cone-shaped points on the crimping plate of the MI crimp tool. Apply even pressure on the spacer disc by tightening the tool until the spacer disc is snugly seated inside the opening of the pot, and the cone-shaped points have crimped the side of the pot. This will retain the spacer disc in position, and the termination is now complete. It is normal for mastic sealing compound to squeeze out the side of the pot. Just clean it carefully. To end the termination, test the insulation resistance of the cable once again with the megameter set to 500 volts DC to ensure that the cable has been terminated correctly. Again, if unsure on how to perform an IR test, watch our supporting video performing an IR test. Finally, to secure the terminated cable end to the enclosure, simply install a user-supplied lock nut onto the gland assembly and slide it into the enclosure. Place a second lock nut on the gland assembly from the inside and tighten it to ensure that the gland is properly grounded. Once the gland has been installed in the cabinet or panel, tighten the gland nut to the gland body using 2 wrenches and ensure that the assembly is fully secured. This now completes the proper termination of a System 1850 multi-conductor MI power cable using the Pyrotenax Pyropak termination kit.